Hi friends, we are going to learn on Kirchoff's current law, which is known as KCL, and with solved problem. Before we study Kirchoff's law, we must just have a glance on Ohm's law. The statement of the Ohm's law is at constant temperature, the current through a conductor is directly proportional to the potential difference between its ends. So, V is directly proportional to I. In order to make a mathematical expression, we just introduce a constant R. Hence, the Ohm's law equation is V is equal to IR. Here V represents voltage in terms of volt is the unit. I is nothing but current, the unit is ampere. R is resistance, the unit is ohm. Next, Kirchoff's laws. Ohm's law is only applicable for simple circuit, but most of the circuits are complicated. For example, the simple circuit is just like that, having only one battery and some resistors are connected in series or parallel. In the case of complicated circuit, according to this figure, there is only one battery and so many resistors are connected in series and parallel. Sometimes the batteries may be given to like this, in between B and C it may be connected. This is complicated circuit. In this diagram we cannot apply Ohm's law. So, the German scientist Kirchoff just proposed two laws, namely Kirchoff's current law. The second law is Kirchoff's voltage law. Kirchoff's current law may be known as KCL. Kirchoff's voltage law may be called as KVL. Let us see Kirchoff's first law, that is current law or KCL. Current means flow of charges. So, when a current enters in a path, it should leave at some other path. Thus, minimum one entry path it requires and a minimum one leaving path is essential. Let us consider this figure. Here OB the junction. From this animation we observe some currents are moving towards O, some currents are moving away from O. So, here I1, I3 and I5 are moving towards O and I4 and I2 are moving just away from the junction O. Now, we are going to discuss about the algebraic. Algebraic is nothing but studying about the positive and negative, isn't it? So, we have to assume that if the currents are moving towards the junction, you have to assume that they are all positive currents. When they are away from the junction O, they are negative currents. So, for this assumption, we can write as plus I1 is not required to put the symbol plus in the very beginning. So, I put I1, then what about I2? I2 is just away from the junction. So, I put minus I2, I3 is towards, so plus I3. I4 is just away from the junction, so I4 minus I4. I5 is towards junction, towards means positive, so plus I5. So I1 minus I2 plus I3 minus I4 plus I5 is equal to 0. We take it the minus sign to the right hand side. So I1 plus I3 plus I5 is equal to I2 plus I4. From this equation, we come to conclude that I1, I3 and I5 are moving towards, that is entering currents. I2 and I4 are moving away from, that is leaving current. Hence, that equation may be written as I entering, I means current, entering current is equal to I leaving. So, what is the statement of Kirchoff's current law? That is first law. The algebraic sum of the currents meeting at any junction is 0. Algebraic means the plus or minus sum of the currents. So, algebraic sum, that means plus or minus of the currents meeting at any junction is 0. So, from this statement we come to conclude that the current cannot be stored at a particular point. Let us work out a problem on Kirchoff's current law. The question is, find the value of the current X. The figure is given. So, according to this figure, what is the entering current? Yes, 0.5 ampere is the entering current. Remaining all the threes are leaving current, 0.3A and 0.1A and X. What is the aim of this problem? To find out the X value. So, you have to give a name at a point A and point B. So, what is the solution? Towards the junction A is equal to 0.5A. So, the 0.5 ampere is just divided into 2. Leaving from A to up, that is 0.3 ampere. Then what is the remaining current? 0.5A minus 0.3A, which is nothing but 0.2 ampere. So, the current is just leaving from the point A is 0.2. Moving towards B, which is also 0.2A. Further, the 0.2 ampere is splitted into 2. Leaving from B to right hand side, that is 0.1 ampere. Then what is the current which is passing through that downward resistance? That is the X value. Just subtract 0.2 ampere minus 0.1 ampere, which is nothing but 0.1 ampere. So, the X value is 0.1 ampere. This is logically we derive, but in mathematically you can write it very easily. What is entering current? 0.5 ampere. But entering current which is equal to leaving current, we are already discussed in that Kirchoff's current law. Entry current is 0.5 ampere, which is equal to, what are the leaving currents? See the red arrow marks, 0.3A plus X plus 0.1A. Here 0.3A plus 0.1A, which is nothing but 0.4A plus X. Next equation, X is equal to 0.5A minus 0.4A, which is nothing but 0.1A. So the X is equal to 0.1A. In this way, we can found that value of current X. Thank you.